Okay, so we're going to finish up the notes on 2.1 and 2.3. The limits equation that we have been working on with is so frequently used that it has a special notation that I already told you about. That's called prime notation. So f prime of c, which we read as f prime of c, also called the derivative of f, is used to denote the slope of the tangent line of the function f of x at x equals c. Therefore, f prime of c, which is also the derivative of f of c, is the limit as x approaches c of f of x minus f of c over x minus c, the thing we've just been working on above. We will call f prime of x the derivative of f of x. And we got one more problem to do for the notes. If f is a function for which the limit as x approaches -2 of f of x minus f of -2 equals over x plus 2 equals 0, then which of the following statements must be true? This is an old AP question. So it says there must be a vertical asymptote at x equals -2. Well, you look at this and you think, well, it's going to be -2 would give me a vertical asymptote, but the problem is we're doing limit, and limit is as it approaches -2. It doesn't really reach -2, so therefore this one is false. It is not that one. And some people like to think that's what it is, but we don't actually get to -2, so we don't count that one. The function f is continuous at x equals 2. Well, we don't really know for sure, but we don't think it's, actually this should be at -2, not +2. Actually, I guess maybe they do want to, because this graph, well, now they want -2 because it's got to be 0. So that's a typo. That should be a -2. But that is, again, we're not sure. So we can't say that's true or not. The derivative of f of x equals -2 exists. Well, since this tells me that there is a value of 0 that comes out of this, that tells me that the third one, C, is the one that's true, because there has to be if you get a number out for this, then there has to be a derivative there. And then this says f is not defined at x equals -2. Well, it has to be defined in order to get a derivative. So that's why this is false. In other words, you can't do a derivative if there's no point there. That's something we'll learn later, that a graph has to be continuous to even do a derivative. So C is the answer. Hope you guys have a great weekend, and I will see you on Monday.